thức và cơ hội sẽ bắt đầu ngay bây giờ. Xin lưu ý rằng hội thảo này sẽ được tiến hành bằng tiếng Anh và có dịch đồng thời sang tiếng Việt. Vui lòng đến cửa ra vào để mượn tai nghe.
Good morning, ladies and gentlemen. AI for automating the convention fabric inspection process of textile and apparel industry, challenges and opportunity will start now. Please welcome Professor Kevin Wong, Mr. Eric Sham, and Mr. Barry Tai. Thank you.
This is one more. Hi everyone. It's my pleasure to deliver a talk about using AI to automate the conventional fabric or textile material inspection process. Before that, please allow me to spend 2 minutes to introduce, the background of AID Lab. AID Lab is jointly established by two universities, the Hong Kong Polytechnic University and also the Royal College of Art, London. And the mission of this laboratory is actually to carry out a series of applied research activities, and the research outcome would be commercialized, which can be used by the industry. So this is our mission, of establishing this AID Lab. Give you some environment about our lab office and also the laboratories. We are located at the Hong Kong Science Park. Under the lab, we have, the 4D body scanning, 4D foot scanning, hair scanning facilities, and also the fashion AI and intelligence textile inspection lab, and also, the GPU to process, a huge amount of image data, because most of our projects are based on the image data, for AI model training and also the algorithm development. Okay, going back, to the topic today. All of you must know that, we are facing a pain point, in the textile and apparel industries, particularly, about the fabric inspection. I'm sure you must know that, in the global textile and apparel manufacturing industries, basically, I can't say 100%, but I project, say, 99% of the factories, whatever, the textile mills or the garment factories, they still rely on human eyes, to identify the location of the defects. So, of course, this kind of manual practice is unreliable. Say, for example, based on experience and even the literature review, around 60 to 70% inspection accuracy. So it means that 30 to 40% of the defects, undetected defects, will go to the downstream operations. So which will cause a lot of problems in manufacturing and also the material wastage, right? And also the accuracy and also the efficiency. The industry norm, for inspecting, the fabric is around 8 to 12 meters per minute. So it is very inefficient. So this is the reason why, particularly, for those medium-sized and large-scale, textile mills, they almost, spend 20, 30, or 40, inspection machines, traditional inspection machines, to inspect the fabric, to check the quality before delivering, the fabric rolls to the garment manufacturers. But another very ridiculous point is that once, the garment factories receive, the fabric rolls delivered by the textile mill, they do the same thing again, right? Because even for those, I observed that even for those vertically integrated, textile and apparel manufacturers, even the textile mill has done the 100% inspection on the fabric. The downstream, garment factories, they still inspect the fabric rolls again. So it is very ridiculous, time consuming. So this is the reason why right now, our current practice in fabric inspection or the textile material inspection still heavily relying on human, But in the recent 10 years, quite a number of AI technology companies have already launched the AI inspection on the textile materials. Just in China, we have come across around 7 to 8, that kind of AI technology companies promote this kind of, AI technique, for helping, the textile mill and apparel manufacturers. But right now, up to now, we can't see that any factories, they are adopting, the AI inspection on large scale. So it means that even right now we have a very strong, AI model, AI techniques, particularly in these 2 to 3 years, we have ChatGPT, Midjourney, DeepSeek, very recent, good technology. But, the factories are still relying on human. Why? There are some challenges. The first one is, that our textile material has so many kinds, of textures, and also patterns, and also so many types of defects. But the point is how we can just rely on one AI model to detect different types of defects. Particularly, for different brands, different textile mills, different factories, their standards are different. For example, for the same type of defects happening on the same type of fabric structure, for this brand, they consider this is a major defect. But for the others, they don't think, this is not a defect. So how we can only rely on just one AI model to detect different types of fabric structures to fulfill different requirements, different inspection standards of different brands and clients is impossible. So this is the reason why, sorry that it is, the marketing and promotion of AI did. So this is the reason why, 5 years ago, we have kicked off a project to develop an AI inspection machine, particularly, for the textile material and fabric. And in my experience, actually, I have kicked off, that kind of research over 10 years ago. But at that time, because of the technology of the industrial camera and also the advancement of AI model were not that mature. So that's why I just limit, to the basic and fundamental research. But once, we have AID Lab 5 years ago, we kicked off this project to translate, those theories and also the embedding with the advancement of the camera and also the AI model in the past few years. We can successfully develop a standalone AI inspection system. So that's why under AID Lab, we have just, spun off a company called YSI Automation Limited, to market, the AI inspection technologies for the fabrics. So to address, the challenges which I have mentioned, we are adopting, the computer-human interaction model. Having said that, because different clients, different customers, they have different inspection standards for different types of fabrics. So what we are now doing is that once the factory is adopting our system, once to start the machine, our system can see whether that type of fabric structure which has already been detected. And then we can retrieve, our AI model specifically for that kind of fabric. And then the factory or the QC, human QC can operate, our system, based on that kind of AI model. If the fabric, the fabric type is new, to the AI model, that kind of, fabric has not been, detected. We can, use our base detection model, which is very robust. Because in the past 4 to 5 years, we have collected over 200,000 images of fabric defects to train up a very robust AI model. So once our model can detect abnormalities on the fabric surface, our system stop and then let the human QC to verify whether it is the defect, a real defect or a fake defect. And then based on this process, our AI model can adjust, can learn, your standard. And then maybe next time, maybe after a few number of batches, we can totally understand your standard for that kind of fabric. And next time when the same batch of fabric come to the factory, we can use that kind of specific AI model to inspect this fabric roll. So this is a reason why gradually for the factory they have different types of AI model tailor-made for different types of fabric according to your standard. So this is the reason why quite a number of factories have already adopted our system. So we can adjust the pain points of how we can use AI effectively to meet the requirement of the industry. So which is very different from the other AI technology companies in China and the other regions. So the core part is this part, the human feedback and also the human AI model interaction to learn your standard. But this process is very quick, just maybe a few number of fabric rolls, we can understand. We can continuously, not me, not the engineering team, it's the model. Continuously, adjust, the model to cater for your requirements. So this is, the niche technologies. What we have developed, we have a very specialized defect detection model trained by over 200,000 images of fabric defects. So this is very robust. And from day one, we have embedded, the AI technologies with the textile trade knowledge. So that's why we can really understand, the requirement of the industry. Other than detecting, the fabric defects, we can also classify the types of defects based on a multi-model classification model. Because which is very important, for the textile mill. They can understand, the distribution, of the number of defects on different types, such that, they can do more analysis to improve the quality of the fabric in the future. And having said that, we have the online learning capability of our AI model, which can continuously adjust, the model to cater, for different types of standard from different factories. We have very strong advanced client server inspection system architecture to process a large amount of fabric image data on real-time basis and then make a decision for the factories, on inspection process. So I would like to show you a video, the actual operation of this machine, which we have developed.
In global textile and apparel industry, the inspection of textile materials relies almost exclusively on human visual inspection. However, the inspection results are often unreliable and inconsistent. WiseEye is an intelligent textile material inspection system embedded with various advanced AI technologies, which can automatically and accurately detect fabric defects in high-speed and real-time inspection environments. The intelligent inspection system, providing AI-assisted and fully automatic inspection mode, revolutionizes conventional manual inspection in the textile and apparel industries. Its inspection accuracy is greater than 90%. It is efficient and provides high-speed inspection at up to 35 meters per minute. The AI-assisted mode can facilitate the WiseEye system to understand more about specific inspection standard of the client. A customized inspection model can guarantee the inspection accuracy. The fully automatic inspection mode can maximize the system's inspection speed to achieve the highest inspection efficiency. WiseEye can inspect common types of fabric with different colors and patterns. In addition to automatic and efficient detection of the location of defects, WiseEye can also help in classifying over 40 common types of defects, grading the defects based on 4-point or 10-point inspection system, and physically auto-labeling the defects. When the inspection is completed, it will provide an inspection report with a detailed defect location map. WiseEye is not only a technological breakthrough that meets industry needs, it also marks a significant milestone in the quality control automation for the traditional textile and apparel industry.
Okay, I just want to show you some, examples what the WiseEye system can detect. So, which is the example of the woven fabrics, knitted fabrics, and these are the key features, of our WiseEye system for defect detection, defect type classification, grading according to the 4-point or 10-point, inspection system used, in the factories. Auto tagging, labeling, we can automatically generate the inspection reports, based on the standard, and also archive, the defect location map in terms of XY coordinates. So this kind of data can also be integrated with, the market planning or the cutting system in the future. So if you would like to know more about details of our technologies, you can scan our QR code, whatever the WiseEye or AID lab. This is what I would like to share with you. And then we move to the next panel discuss section. So I'll pass it to Barry.
Good morning, ladies and gentlemen. Now we come to the panel discussion session of today. And we are glad to have Professor Kelvin Wong and Mr. Eric Shen to be our panelists. And I'm the panel moderator of today. I'm Mr. Barry Tai, Senior Manager of AID Lab. And we have already listened to the very detailed and interesting introduction of Professor Wong. He is a professor and also now an entrepreneur in commercializing academic research into commercialized technology solutions. And we have another panel member, Mr. Eric Shen. So before I start my question, may I invite Mr. Eric Shen to have a brief introduction about yourself, please?
Hi everyone, good morning. Looking from my hair, actually comparing with the academic qualification, and a little bit far away from Professor Wong, okay. But I involved a lot of experience in the industry, okay. Academically, I'm professional in textile and clothing, business, and operations management. And my accumulating experience, starting from almost over 40 years ago, I involved in the purchasing of the materials, management of the factories, and finally, within these 10 years, also involved a lot of the R&D in the innovative machineries and create our own machines to use and adopt in the factory. Most of these factories are the industry and clothing factories. So this is just a little bit experience in my field, to see whether I can share with all of you in some of these questions you may ask.
Thank you, Eric.
Starting from Barry first.
Thank you. So we are happy today we have a good combination of panelists from industry and also from academic. And today's topic is AI for automating the conventional fabric inspection process of textile and apparel industry, challenges and opportunities. And actually I've prepared a list of questions to ask two of you. And my first question will be to Professor Kelvin Wong. From your presentation, we know that you are now commercializing innovative technology from a research project. What do you think textile companies should prepare for when they are considering adopting AI technologies and products in their factories?
Okay, thank you, Barry, for this question. Actually, even in the past 2 to 3 years, AI is really a very hot topic. And even, most factories have approached us, how to implement AI, like, the example of fabric inspection. This is a very good example. But the point is, which is a kind of learning process. Even though, the current AI technology is, I would say, is quite mature, but, when we apply AI in a specific, sector or in a specific operation, it takes it takes time. It doesn't mean that, like, even for the factories, when they are very interested, in the Wi-Fi inspection machine, it doesn't mean that once, we deliver the inspection machine to the factory site, they just need to, switch on the motor and then all the things done, no any human to be involved. It's not the case. It's still, the learning process, because it takes time, like what I have discussed in example. It takes time for AI model to learn your standard, to learn your practice, and then the factories still need to set aside the resources not only about to pay to buy the system, to buy the AI system, but they still need to have a team to support the project, instead of just because when we employ AI in a real life situation, we still need to have human thinking. Let the AI, to learn what you are now practicing in your operations. So it takes, in example, for the inspection machine, it takes 3 to 4 months, such that, we can successfully deploy, the whole system, AI system, in the factory site. So this is the reason why the textile mills or the factories, industries, they need to adjust, I can't say expectation, but adjust their mindset, how to make preparation. Not only just to pay, to buy, but still need to have a team. Maybe, the IT team, the engineering team, or those operations involved in that kind of AI development. They need to invest in manpower resources to cooperate with the AI tech company or the university to kick off and then to implement the whole project. So this is my advice.
Thank you, Professor Wang. Seems it is not an easy process, but a challenge is always an opportunity. So we have just heard about some valuable insight from Professor's perspective. How about the industry? So may I ask Eric, from your industry perspective, what preparation do you think companies need to take? And how can they better collaborate with technology teams like Professor Wang's team and academic to ensure the successful implementation of new technology in their factories? Thank you.
Okay, thank you, Barry, for your questions. I'm not saying I'm the representative of the industry, just to represent on my personal will, experience, and have a say here in the industry for more than 40 years of experience in the industry. Everything for the preparation, I don't know how many entrepreneurial will be sitting here. All the changes, we start from the top to the bottom. If the industry or the company without an entrepreneurial thinking from the top to cut a change in the industry, there's no success or fail. Because you can't expect your subordinates, your employees to drive the top, to have a change. Every talking about the AI, if Trump is not saying the AI, no Americans are doing AI. Even the AI right now with the DeepSeek or OpenAI, it's all challenging. Everything is changing. But from the top, got to change is that we have to dedicate all those thinking and obligation to your employees to make your company grow. How to change that? Talking about that, give them responsibility, give them a sight of technology, give them ROI, return of investment, give them an idea. What is the profitability? What is the efficiency in the industry? How you boost it, how you make the growth in your industry. Give them this and dedicate them this power to think. I think the next step, your people, your employees will think about how to change your company in a better position. Without this, from the top, from the right person, you expect your subordinates to have a change. This is not a change. So, what the preparation is a change from the top. That's the preparation. That's what I want to focus to say.
Thank you, Eric, and thank you both of you for sharing your thoughtful insight. And I think the time is up. So I'm sure all of you would like to continue the conversation with Professor Wong and Mr. Eric Shen. So welcome to visit the booth in Hall A, K16, which we are showing the real AI fabric inspection machine here. Thank you very much. Thank you.
Thank you. Thank you. Thank you.
So we have a Q&A session. Any question from the floor, you can raise up your hand and our colleagues will. Okay.
Hello, thank you. Courtney from Burr. I'm a textile technology developer, so I work with global mills and want to be able to apply this type of technology. My question is that I used previously a North Carolina technology called Uster, USTER Technologies. I'm curious what you think about their EVS system and who are the other competitors to WiseEye.
Sorry, I cannot answer your questions. May I focus and want to see something? What do you really want to ask? Competition. Oh. What's the next? Okay. You know, it's nice to see that at least a person to talking about the competition in the market. I can say that within these 10 years or even the 5 years, focusing in these 5 years, there's a lot of the industries emerged in the market talking about this AI. Same thing is in Europe. I think mostly in Europe, I can say that. I cannot talk about the brand. There's the competitors. First of all, is talking about the system, how sophisticated they have compared with ours. First thing. Second thing, the pricing. Whether the pricing is compatible with the industry and the boss willing to pay. How they calculate the ROI. This is the second question. We are proud of our machine WiseEye. It really can perform above the market. How to see this comparison? I cannot target to say that the other industry are not good. But the thing is, I just got the feedback from the market, from the user. Oh, no good. Accuracy is so low. They cannot manage so many things. That's why, even continue today, we can also collect some feedback. Actually, in the market, still not yet mature. That's why I'm happy, because the competitors are still working something. I think it's good to the industries, because we are working for the industry, textile clothing, especially for the industry for 40 years, 50 years ago, almost adopting the same manual technology. The thing is, I'm not, one of the wording is very beautiful. I'm not talking about is the deployment. How we deploy these AI technologies in the industry. Most of the industry fail because they cannot deploy. Just thinking AI can help everything. The thing is deployment. We work with the industry, how to work hand in hand and give you a real picture and give you the real performance, and that can say that you can reduce your cost, you can improve your efficiency, and the next, how you manage with the data. Once this data, if you can manage, you can make a good smooth in the industry to perform the right thing. Because from the data, you can analyze. We are not talking about some analytical model. That actually is another model we can help you. There's going to be. This is just a bit of our.
Maybe I would like to supplement some points. How we can adopt, the whole industry can adopt, that kind of AI technologies, inspection technologies, successfully. It's about, the widespread adoption, but right now we couldn't see it. I think, from commonist point of view, there are two things we need to consider. The first thing is whether the price is reasonable, right? Even, because we in the market, there are some sort of, AI inspection machines talking about, $2 to $3 million Hong Kong dollars just for one inspection system. I don't think that, factories in Vietnam, China, Cambodia, they could afford, right? This is one thing. Another thing is, the performance. Having said that, in my presentation, it's about, whether, the inspection system can really meet, the current industry requirement. Catering, for different types of fabric, different type of structure, different types of standard. So this is another thing. So if get that two kind of things, I would say mature. I'm sure that we can see the widespread adoption of that type of AI system. But right now we can't see it.
Okay, so thank you for the question from the floor, and I'm sure now the time is up. And please feel free to talk to Professor Wong.
And the last question, just to say, if there are any more questions, you are welcome to go to the booth. What's the number?
Hall A, K16. Hall
You can talk, you can share.
Yes,
Anyway.
we have already a machine there. We can show the live, which is the live demo. You can see the details and also the whole operation of the system. Yes.
Thank you.
Thank you very much.
Thank you very much.